about the variability of the slope of the regression line. When we looked at the baby data, we saw a slope of somewhere about 0.4 ounces per day. But that slope estimate was based on a sample. And our sample might, have been different. So since the slope depends on the sample, one question you might have is, what if the true line is actually flat? How do we know there's any slope there at all? Well, we could test that. We could use hypothesis testing. The null hypothesis, remember, null hypotheses usually have an equality statement in them. The null hypothesis here is that the slope of the true line is 0. And the alternative hypothesis is that the slope of the true line is not 0. Our method for testing this would be to construct a bootstrap confidence interval for the true slope. Maybe a 95% confidence interval, for instance, if you wanted to work with a 5% cutoff level. If the interval that you create doesn't contain 0, that means 0 seems like it's not a reasonable number for the possible slope. And in that case, you would reject the null hypothesis, right? We would say then that the statistical evidence favors a non-zero slope. If the interval does contain 0, however, then there isn't enough evidence to reject the null hypothesis. And there, we'd say that we fail to reject the null hypothesis, and we have to admit that it's possible that there really is a slope of 0. Let's look at this in an example in the demonstration. Remember this example, we were working with the baby weights, and we were predicting baby weight based on the number of gestational days. And what we found was a 95% confidence interval for the slope of the regression line, indicating that we had a slope between 0.384 and 0.559. Now, if we wanted to test the claim that the slope is 0, what we would do is we would look at a certain cutoff level. And here, it's convenient to use a 5% cutoff level because we already have a 95% confidence interval. If we wanted to use like a 10% cutoff level, we could use a 90% confidence interval instead, right? We'd have to redo the confidence interval calculation there. But here, let's use the 5% cutoff level. And since 0 is not between 0.384 and 0.559, we would conclude at the 5% cutoff level that 0 is not in this interval, and hence we would reject the null hypothesis and say rather that the statistical evidence here supports the conclusion that the slope is non-zero and that gestational days in the womb are related to the birth weight.